thank you everyone for attending today's Argilla's community meetup. Today we have Ayush and Bharat from Weight and Bias. And yeah, they will be explaining us how they optimize and evaluated LLMs applications. And yeah, in this case, applied to OneDBBot, which is a cool application they built for question answering. Yeah, questions related to weight and biases. So yeah, the floor is yours, Ayush and Bharat. So yeah.
Thanks. Yeah. Bharat, do you want to kick off?
Yeah. Hey everyone. Maybe before I start talking about Wandbot itself, I'll just quickly introduce myself and maybe I can go next. Yeah, I'm Bharat and I'm a machine learning engineer at Weights and Biases in the growth marketing team. And I largely work on building integrations for Weights and Biases. And for the last year, I've been working on building some LLM based applications, both internally for internal and external usage. And yeah, and Wandbot is one of my pet projects that I've spent a significant amount of time over the last year, and I'm excited to talk about it. Yeah.
Yeah, thanks for that, Bharat. Yeah, myself, Ayush Thakur. I also work at Weights and Biases. I am also a machine learning engineer like Bharat in the same team. I have been doing a lot of stuff here, but mostly focusing for the past 2 years, I would say, making integrations with different frameworks and libraries. And for the past 1.5 years, I have mostly been working in the field of language model and doing evaluation and building applications, writing about RLHF or RAG, or doing this, and also helping Bharat with Wandbot and Wandbot evaluation. Yeah. So having said that, this project Wandbot is something that has been done over a span of more than a year now. A lot of things have changed, and it's a really production grade RAG pipeline that our users are using. In both in Discord and we are using internally. And yeah, we would love just to talk about it, how we evolved it, and how we use Argilla with the to do our annotations and labeling and all the different debugging that we did, evaluations that we did. So yeah, just here to share a story with you all. I hope you like it. Bharat, over to you.
Yeah. Okay. The major topic of this presentation is going to be Wandbot, and we'll go over the evolution of Wandbot over the last year and how we conducted evaluations and the design considerations we had to take into consideration when we were thinking about evaluations, and how we built an auto evaluation pipeline, and then at different stages the kind of evaluations that we ran and how we use Argilla at various stages. And then we can probably take some questions towards the end. Yeah. Okay. So Wandbot, right? Wandbot was imagined as a conversational developer assistant. It's open source, so you can go check out Wandbot's GitHub repository. Initially, we released Wandbot in our internal Slack so that we could play with it. And the idea began as part of a hackathon, and we wanted to learn more about LLMs and LLM applications and how to build RAG pipelines and the kind of experience that developers would go through, and therefore the kind of tooling that Weights and Biases could build to support a developers experience building LLM applications. And over time, we got more confident with Wandbot internally and began to release it to our community on Discord. In as an overview, it started off as a simple RAG pipeline, a retrieval augmented generation pipeline. And yeah, over time we evolved it at various stages. Initially, I will talk through the different evolution stages of Wandbot. It might be it will be a quick summary of the different stages, but we will also dive into each stage and the considerations that we had, or the story of how we evolved each stage as we go through the presentation. So yeah, so our initial V0 version 0 of the pipeline, which was released in our internal Slack, was a very simple pipeline. It had two stages. It had an ingestion stage and a chat stage. The ingestion stage, largely because this was built as a document Q&A bot over our documentation, some of the major things that we ingested were our own documentation, which resides in our documentation website, some of our SDK code, and some tutorials and examples that we have written publicly for people. And the ingestion stage largely involved parsing some markdown files, parsing the code files in our SDK repository, and parsing some Jupyter notebook files. Parsing here largely meant keeping the structure of those documents and removing away elements that an LLM could not process, for instance, images or URLs that resulted in hallucinations. So therefore, we removed away URLs, we removed away images, and we still kept the structure of the whole document. And then we introduced a pre-processing stage wherein the main goal was to split our documents into usable chunks. Initially, we started with GPT 3.5 when it released last year around February. And at that time, the longest context size was about 4,000 tokens in an LLM. So therefore, we had to go through rigorous chunking strategies and look at how we could chunk code differently versus markdown differently, and also add some metadata information about where these blocks were sourced from or chunks were sourced from, and then ingested all of this into a vector database. Our initial vector database was initially we did not have a vector database. We just had a NumPy array, a NumPy matrix that stored embeddings, and we used OpenAI embeddings. But then as we deployed it to Slack and we wanted some amount of persistence and resilience, we started using FAISS store. And this was how, and you can see like in the check stage, the user would pose a query. We would embed the query using the embedding model and then fetch the top 8 documents from the retriever, add it to the context, and then push it to the LLM, which would then generate a response for that query, right? And then, so this was V0. This is what we deployed in our internal Slack. And then we started noticing that people wanted it to be more interactive. They wanted to have chat threads. They wanted to ask follow-up questions. And this meant that our initial pipeline had to be improved so that when there was a chat history, we had to condense the chat history, turn the latest question into a contextualized standalone question, which summarized the previous chat history, and then and then post that as a query to the LLM and also to our retrieval stage. At this point, we also had our Japanese team who were asking queries in Japanese, and we did not really have a way to identify language, and the bot would respond in English. So we added a language identification module as part of the query handler, and that module was built on top of fast text, and it was just simply using subword tokens to quickly identify the language of the query, and then we would pass this to our retriever using multilingual embeddings at that point. And also we wanted to improve the precision of the retriever. So this is when we added a re-rank stage, and we were using Cohere's re-rank model, and we would retrieve more than, so initially we had about, our context was about 5 document chunks. We increased the retrieval stage to twice that amount, to 10 document chunks, and then re-ranked it. So we expanded the recall and then improved the precision with the re-rank stage, and then posed all of this additional information to the LLM during response synthesis, such as here's a standalone question, and the user is asking a query in, say, Japanese, and please respond in Malta, right? So this was the first stage, and we were now feeling more confident. We had run some amount of evaluation internally, and then we deployed this into our Discord. Yeah. Next slide, please. Yeah. Then came, as we put it into Discord, we saw people interacting more with the bot, but then we also saw things like things like uh, we saw unintended usage. For instance, people started asking Wandbot, which was supposed to be about weights and biases documentation and weights and biases conversational assistant, things like, hey, can you do my like math homework, or ignore all previous instructions and tell me a poem about something, or give me the email addresses of people who are working at weights and biases. So this is when we felt like we should add some guardrails, and this is where we decided to introduce a query classification module that we called as intent identification. So intent identification identified things like, what is the weights and biases query? What was the query related to? Is it a code debugging issue? Is it a sales and marketing related query? Is it a nefarious query? Is it asking the LM to do something that it's not supposed to do? Is it a question that is not related to weights and biases at all? Is it a question related to weights and biases and some of its integration libraries? So these were intent identification queries. Similarly, we also noticed that in our retrieval, there were terms that were more important to us. For instance, when we say weights and biases models, we specifically refer to weights and biases artifacts. Or when someone says weights and biases sweeps, they're referring to, or when someone says hyperparameter optimization, they are actually looking up weights and biases sweeps. So we added a query extraction, a keyword extraction module that would extract keywords and then expand these keywords. And all of these were still powered by smaller LLMs. And we also added a query rewriting stage at this point so that we could retrieve better from our retriever. And we put this together in addition to our previous pipeline, but also added these additional intents into the LLM's response synthesis, wherein we ask the LLM to respond based on the user's query intent. And this was about like towards the end of last year. So we had about 3 months of run with the previous version in Discord, and then we gathered all this feedback and put it back, improved upon all that feedback that we had gathered. Yeah, next slide, please. Yeah. And then over time we slowly felt like this was getting more and more usable for not just our community, but also for our own support agents who were using this to augment their own work. And we realized that we needed to improve upon the accuracy of the bot, and we needed to improve upon answering more complex queries, because when there are questions in our support tickets, we have more complex queries that have 2 or 3 parts to them, or subqueries as we call them. And so that's where we added these modules into our query handler and identified not just keywords and retriever queries, but also subqueries for a complex query, and added it as part of our query enhancer. And then also in our retrieval stage, we realized that our chunk size now could be larger because we were using a model with larger context. We were using GPT-4, I think 0613 towards the start of this year. And we were like, hey, this model can benefit from using larger context. But then when we started ingesting larger context chunks into our retrieval performance was dropping. So that's where we said, hey, let's do parent document retrieval, wherein we would embed smaller chunks. But then once there was an embedding hit, we would then source the parent document from which these smaller chunks were there. And these parent documents were just a larger window around the child documents. And then we then ran that through the re-ranking process and follow the same response synthesis. But in addition, we also added the subquery enhancements to our response synthesis module so that the LLM could not just respond to the initial parts or to like one part in a query, but also different parts of a query were being pulled out to have a response for, right? And so this is like a quick rundown. I know it was very quick, but we will go through each of these stages as we talk through the next parts. Yeah. So all of this was obviously done through like each of these improvements from V0 to V1.1 and V1.3 was done through evaluation. And my partner in crime, Ayush, was doing most of the evaluation work. This was also for us to have not just a separation of responsibility, but also to reduce the amount of bias me as a developer would have when looking at something that I'm building and not looking at so much of the test data while I'm building the pipelines. So I think Ayush will give a good perspective on the optimization the evaluations that we ran and how it influenced each of the pipeline changes.
Yeah, thanks for also for those who are confused as to why we talked about V0, V1.1, and then jump to 1.3. 1.3 is just like an internal thing that we are calling. It's actually 1.2. It's not skipped over. If you look through our Wandbot repository, you will see the release tags. It's going to be 0, 1, and 1.1 and 1.2. Just because we are habituated of calling that 1.3, I will be also using that. But remember, that's 1.2 over 1.3. Yeah, when we were trying to design evaluation, Bharat mentioned that when we had V0, we had that for internal usage, and like they were a very small usage, but over time we were able to collect some data by our users and everything, right? When we were designing, like improving over the first version, we were considering as well what are gonna be our different evaluation criteria. We thought that And these are like quite obvious. Like even if you have your own use case, you might go through these challenges and come through these considerations as well, more or less. The evaluation set has to be very reflective of our user base, right? Obviously, if we are talking about WandDB documentation, the evaluation should be around that as well, right? Because the users are supposed to ask that. There should be some edge cases to test those nefarious queries, the queries that are not related to weights and biases, but those should also be part of the evaluation set. But overall, it should be documentation, right? So the second thing is that we should be able to have a good metric to capture what our audience is trying to think about, right? Overall, we kind of settle on the fact that the response that has been generated by our system should be as accurate as possible, right? We relied on the accuracy of the response generated, the factfulness of it, and the relevancy of it, right? These are the three things that we considered evaluating thoroughly. And then also we needed to be sure that, because again, this evaluation is part of the development cycle. We cannot like for every single time there's a change made, we go in and hire some annotator and do some manual evaluation, right? That's not possible. That takes a lot of money and also a lot of time as well. We needed to optimize for both time as well as money. And lastly, and this is true for like most of us, that when we have a system like this, like today's LLM based systems, they are not deterministic, they are quickly evolving, and thus we have to be very comfortable with the fact that our evaluation strategies should be evolving as we are evolving our system, right? We might be using the same evaluator set for maybe evaluating one or two versions, but as we move forward, as we learn new things about the behaviors of our user, how our system is reacting to the queries being asked, etc., we should also evolve those data sets as well and the metrics as well, right? So just I will just quickly skim through the fact that these are the three different strategies that we employed in practice. We started with eyeballing, where we picked few responses, rather like few queries, on top of which we were building the whole system. Rather, Bharat was building the whole system. So say there are 5 queries. Is when he tweaks something, he checks if the responses are kind of good looking on those 5 queries, and we move on with that, right? So it's the quickest way of evaluating, and it allows you to build a system in the first place, right? Because if you just go in and do like manual evaluation, it's going to take forever before you build a system, right? So you need to build a system quick so that you have something to deploy something and then get some usage of it to learn more, right? So we started with quick eyeballing. Then we did one stage of, or rather one phase of, at this point, kind of 2 phases of manual evaluation, wherein we had used our internal machine learning engineers as annotators. And given they were domain expert, they know ins and out of weights and biases. So they were domain experts. So we asked them for free lunch that, hey, this is what we have, and would love if you can spend like 1 hour to evaluate a few things. And then mostly we relied on LLM as a judge to evaluate our system. So just to give you an idea, last time when we made the switch from 1.1 to 1.3, and while we were building the system, we ran the evaluation somewhere around 33 times, right? So imagine we cannot have asked our colleagues to spend like 33 hours, 1 hour per evaluation, right? Or we could not, that was not scalable. So we had to rely on a automatic way, which is doing auto evaluation, wherein we say that, okay, fine, we have some response, we have some query, we have some context, let another LLM judge how good the response is. Again, it kind of sounds crazy, but it works as well. But we have to be very careful with it. This is us trying to build the first initial evaluation data set. So the idea here is that since we were able to deploy the first initial version, we were able to collect the kind of questions that folks were asking internally. So we collected all those questions, and we, like at that point, we collected 872 questions, and those were all coming from our Slack usage, right? So yeah, like this is our weights and biases table where you can see the query, the response generated, and as well as the feedback. So the feedback here are folks giving either a thumbs down or a thumbs up emoji react to the response that was generated, right? So that was a way for us to get some sort of indication as to how the responses were are like useful to answer that query in a initial stage, right? So this particular 872 query response feedback triplets were dated back to September of 2023. And as you can see that Also, this is a good case study. Say, for example, in your case, you genuinely require folks to kind of give some sort of feedback about how like feedback on the quality of your response. So maybe you can consider some sort of gamifying that or providing some sort of incentive to the users. Because as you can see in our case as well, there was no incentive to give a thumbs up or a thumbs down after reading through the response. Most of our responses, like 600 out of those 800 responses, were not given any feedback. But luckily, there were like over 150 responses with a positive feedback and some negative feedbacks that we have. So that was a good, like, kind of representation of on which queries the system is get performing well and on which queries it's not doing at all good. So we had that idea. So the next step we thought of doing was, fine, we have these queries. Okay, we can ignore the responses at that point of time because we wanted to have a gold standard set of queries. As if you remember, when I was talking about eyeballing as a technique, we use 5 queries, for example, while we were building the system. So in this case, when we are doing auto evaluation or even manual evaluation, we need to have at least 100, 200 queries, right? So what we did was we employed different clustering algorithms, be it KNN or DB scan, etc. But then later on, like after all the experiments and like doing some vibe check and like some metrics, we realized that community detection, wherein we convert every query as a, like the whole data was converted to a graph, and then on top of that graph, we were doing the clustering. It gave us the best performance. So we did the clustering, we got some n number of clusters, and then we use GPT-4 to sample a representative query per cluster, right? Because again, we wanted to reduce the number of queries, but we also wanted the queries to be representative of what the users are asking in general. Like an extra tip would be here that maybe you can think of doing some sort of topic modeling to understand a distribution better to do sampling, but we skipped that part. We were in a hurry, so we used a powerful LLM at that point to like sample from our clusters. So that kind of gave us somewhere around 130 gold standard queries. So these are the queries that kind of covered all of our product usage, and they were diverse in nature because we went through all those queries manually as well once we had this cluster, this question sample from the cluster. So the first thing, like before even thinking about any auto evaluation, was, hey, fine, we have some questions that we consider to be a good representation of our usage distribution. Let's go ahead and generate responses on all these queries and then do manual evaluation. As I mentioned, folks like machine learning engineers internally were like happy enough to do this for us, and they were domain experts, so they knew what they were doing. So given the query, the response that was generated, we basically asked them, hey, and we also provided them with the context, which was retrieved by the retriever. Hey, given this 3 information, tell us if if the response is accurate or not, right? So we gave them a choice of correct, incorrect, and unsure. After all the evaluation that we did on the basis of the manual evaluation, we get somewhere around 67% accuracy. From a tooling perspective, we used Argilla as our optimal choice for this manual annotation. The reasoning was we didn't want to spend any time building the server side of things, wherein we handle the data. We also didn't want to use spreadsheets. Spreadsheet is very outdated for like tasks like this. It's not intuitive. It's very prone to error. We didn't want to spend time building a tooling ourselves. We wanted to use something that was easy to use. It was free to use and scaled well as well. Again, for our case, we were not annotating millions of samples, right? We were just annotating 132 samples. But it was very tailored well for the LLM use case, and the UX was really pretty. Like when I was building this, I really liked, and I went around and checked few other tooling out there for this purpose, but like stuck with Argilla, and I'm still using Argilla, and we have plans to use even more going down the road. The best thing that I liked about it was the fact that it was very easy to deploy, and that every annotator gets their unique workspace. So whatever is assigned to one annotator, that person is only responsible for the samples that they are allocated. They cannot look into someone else's annotation. So we are not allowing any annotator to be biased by the responses given to someone else, right? And that can easily be like, that's something that you need to build, but Argilla is doing it for us. So great, kudos to them. So we use that. Initially, as I mentioned, like we had 132 samples. So I split those in like different chunks and allocated every chunk to individual annotators. They all had their own workspace, and yeah, and they all had their own credentials to log into their workspace and annotate it, right? From a UI UX perspective, on the left, we had the three questions: the query, the response generated by the Wandbot system, and the context, right? And we asked them to, hey, is the response correct, incorrect, or unsure, right? So that's the thing. We also looked into if the links that were generated were hallucinated or not, and if the question itself was related to weights and biases or not. We did that because at the end, we also wanted to include some of the queries. Like we wanted to reduce the number of questions. The 132 was also a lot because if you imagine when you're doing auto evaluation, you are running your system through 132 questions. That's going to take up a lot of that translates to dollars, right? So we don't want to spend a lot. So we knew that fine, we can reduce the number of queries that are not related to weights and biases, but we'll cherry pick few to evaluate those edge cases. That is why we asked annotators to do that. Right. So the first initial evaluation, auto evaluation that we did, we got this faithfulness score of 53% and this relevancy of 61%, right? These are all being judged by GPT-4 1106 at that point in time. But note that we were simply using Llama Index as default prompt templates. You can imagine that you have a query, response, and some context. You are throwing all that to the OpenAI API along with some instruction. That instruction is the system prompt. So for this phase, we were using the default system prompt that was coming off the shelf from Llama Index, right? And we also evaluated the retrieval using these two metrics, hit rate and mean reciprocal ranking. So we knew that find like somewhere the evaluation that we are getting is coming close to, it's not random at least, this is above 50%. So there's some good signal from our system but we knew that there's a lot of room for improvement. Then this was bet on how we evaluated the system, use Argilla to annotate them so that we have a good idea of which queries have been answered correctly or not. And then we use the simple vanilla auto evaluation strategy. But we needed to evolve the auto evaluation strategy as well, which Bharat will be talking about next.
Yeah.
Over to you.
So thanks, Ayush. Yeah. One of the things that we ran through this cycle of manual evaluation, we knew that we can't keep repeating this every time I had to iterate over some improvements in Wandbot. And we needed a way to take all of that manual evaluation and train like an LLM to evaluate in a similar fashion, to have a correlation to our human evaluation. And that's where we started with taking up that validation data, that 132 questions, and then getting GPT-4, we started fine-tuning the system prompt of the evaluator, and we started adding few short examples from those two questions. And the main goal here was to align GPT-4 as an evaluation judge with our own human annotations. And you can see how we use Argilla again. Here we had our initial human annotations, which were correct, incorrect, and unsure, as well as we also had some notes from our internal annotators. For instance, if someone said some answer was incorrect, they would also point out why that answer was incorrect. And we used that as part of GPT-4's reasoning. We gave that as part of our few short prompts and told GPT-4, this is why we think this is incorrect. And then asked GPT-4 to evaluate all of those 132 questions again, but this time used Argilla's suggestion method to put in GPT-4's response as a suggestion and put it back to our human evaluators and said, hey, here's your previous annotation, here's GPT-4's evaluation of the same thing, here's the reasoning that some human evaluator had given, and here's GPT-4's explanation for why this answer is correct or incorrect based on the query and context, right? And this allowed us to, in this way, we used Argilla to align our LLM judge and the prompting and the chain of thought prompt and the few short examples to our internal evaluation process. So what happened is, hey, can you go to the next slide? Yeah. So what happened is basically we found that in terms of after the second stage of GPT-4 alignment, we found that of those 132 questions, even amongst our own annotations, manual annotations, we found 98 of those annotations were actually correct. 22 of the annotations were incorrect, and 33 of those annotations we were just unsure. We just didn't know why there was no reasoning or match there. So we then used these 98 correct annotations, which had a correct annotation from a user, as well as with GPT-4 evaluating that response as correctly in that it was aligned with the user's annotation as our base gold standard for auto evaluation. Right now we had this roughly 100 queries, and these 100 queries we then used GPT-4 as a judge with a new evaluation prompt that was fine tuned based on that alignment exercise that we did with Argilla, and we scored on three different uh, metrics. We scored for correctness, which was whether the answer was correct or incorrect. We scored for faithfulness, which is whether the answer was sourced from the context that was retrieved. And then we also evaluated for relevancy, which was basically whether the answer stuck to the point of the user's query and did not like deviate from what the user was asking, which like a lot of LLMs tend to do. That is, they tend to ramble around but actually answer the query. So therefore, we checked on these three dimensions. Among these three dimensions, we also look for three different ordinal scores. Here the scoring is ordinal in the sense we said one is that the answer was incorrect, two meant that the answer is ambiguous but it might be correct, and three meant answer is correct. And we found that among various scoring strategies, using ordinal scores or classification based methodology was best when compared to real scores. Rate this answer between 0 to 100 or 0 to 1. We found that strategy to work the best. So therefore, then what we did was we took all the previous deployments of Wandbot, and which had the initial eyeballing deployment, the first version that we had deployed on Discord, and the new version that we had, and we started measuring for these various dimensions or metrics. And yeah, so we used our own. Now we had these new LLM judge prompts that was measuring for relevancy, faithfulness, and correctness. But also we wanted to make sure that this was not very different from prompts from scores that we had in external libraries like Raga. So we also measured across metrics that were available in these libraries like Raga. And yeah, so you can see the radar plot on top shows how with each version we started improving. The changes that we were making were actually improving the performance of the bot. And the last version, which was V1.1 at that time, had improved Wandbot's performance across all of those dimensions. And we were like quite happy that we had made some amount of progress, we had come from like roughly around 51% faithfulness to a slightly higher amount of faithfulness. At the same time, we had improved upon the answer correctness, which you can see as 72% accuracy. Initially, it was like some 66%. And but at this point, one thing that slightly dropped was the context relevance. This was because we were now context precision, because like I said, we were using a larger context model, and we started ingesting much smaller document chunks for a larger context model. And even though we were using re-ranking, we felt like we needed to add better context to our model. So this was one learning that we learned, that we carried away from this exercise. That in addition to having moved some of the metrics, we also lost on some things like the context precision. Right? Uh, yeah. Next slide, please. Yeah. So all of this also told us that, hey, there is more scope for improvement. And that is where I started working on a new refactor, which we call 1.3, because initially there was a 1.2 that I did not merge because there were some issues with the evaluations that I was running at that time. And we discovered that and wanted to make sure that we were doing it correctly. So we skipped 1.2 and went to 1.3. But as a release, we released Wandbot as 1.2. Yeah. So Ayush will talk through how we ran evaluations and the challenges that we faced when we were making these 1.3 evaluations.
Yeah, thanks for that. Yes, when we moved from 1.1 to 1.3, one of the major change was to get away from Llama Index and move towards LangChain expression language. We basically wanted to parallelize the LLM cause for performance improvements, right? So the whole idea for this new refactor beside the improvement in the performance from accuracy point of view, was also to improve the speed with which it can generate the response and deliver it. Our context was enlarged by the time we were in at 1.1, and we were also getting a lot of tricky queries, right? That were, as you mentioned, when we are talking about support tickets, those questions can be really lengthy and in multi parts. So we were like throwing a lot more tokens. So we were wanted to that wherever possible, we parallelize calls and make things faster, right? But while we're doing that, we also obviously moved from FAIS's vector store that we used for 1.1 to ChromaDB vector store that we are using for 1.3. And honestly, that gave a massive improvement in the speed up of our retrieval process, right? There was somewhere around 70% improvement that happened solely because we were switched from FAIS to Chroma. And yeah, we also changed the LLM model. So a lot of changes, like small tweaks and changes were made when this refactor happened. One more change that I need to mention is that in 1.1 in our system prompt there was few short examples, like 3 or 4 short examples. But when this system was prepared, there were only we kind of removed those few short examples. We thought that we are anyway throwing in a lot more tokens, so let's try to save some tokens by removing those few short examples, right? Because you can imagine in those few short examples you will have the query, you will also have all the context. So like for one query you are retrieving say 10 chunks, but you're also giving, if there are 3 examples, you are giving in 30 extra chunks as like examples to look through, right? That was a lot more tokens that we were spending, so we wanted to remove that. So when we did that, interestingly, our initial score, like after all these changes, our initial score was 9%, right? That was way below the 72% mark that Bharat showed recently, right? And we're like, what really happened? Turned out that when we looked through our Wandbot table, like manually checked what the responses were being generated, like you can see that one of the reasoning that our judge gave was that that the generated answer is incomplete and it does not finish the example code snippet, right? And when we look through the answer, it's cut off, right? And we thought, okay, it might be one of case, but we looked through many examples and we realized that most of the answers were cut off, right? And then when we calculated the number of tokens for all these answers, they were all in the range of 240 to 280. So we knew that there is some issue with the max token. Turned out, while we were doing that refactor, we also kind of introduced Light LLM so that we can switch vendors easily. It was more configurable that way. Turned out in Chatlight, which is a LangChain module, max token was set to 256. We didn't know about that, and we ran the whole thing. And later on, when we looked through by using Wandbot table, there was like all the answers were cut short. We realized, okay, fine, we have to look through the code itself to see what is happening. And then we set the max token to 4096, which is what OpenAI is expecting, right? So we did that. The accuracy moved from 9% to 25%. Then again, it was not close to the 70% mark. So we again looked through what the reasoning the judge is giving. And just to give an example, here the judge is saying that the generated answer includes an additional unrelated section about configuring sweeps in weights and biases. And if we look at the question is about Wandbot with Fast API. So someone is asking about how to use Wandbot with Fast API, and it somehow is giving that answer, but it's also answering about weights and biases sweeps, which is a hyperparameter optimization tool, which has nothing to do with Fast API, right? We knew that there's something wrong that's happening with the query handler. So the subqueries that the query handler is generating, there's something fishy with that. We investigated that as well, and we realized that the temperature of the query enhancer was set higher, and that's why it was making things a bit more, and that's why we turned it back to 0.0, and improvement in, like the accuracy improved to 28%. Again, there were a lot more to do because it's not even close to the baseline after the refactor, right? So what I started doing was, while Bharat was like refactoring and improving the system, I started cherry picking all the commits in my separate branch and was evaluating every commit one by one to see, hey, okay, change was made in this commit. Maybe it was a simple change of switching from GPT-4 1106 to GPT-4 0125. Let's evaluate that, okay? Because we cannot just switch anything without evaluating it properly. So that is what I was doing parallel to what Bharat was doing. I'm showing that after this whole debugging process that went in, it was again a very tedious process because you can imagine that pick few comments, make them work in your local system, then evaluate them, and evaluation takes some time as well. Initially, it was taking somewhere around 2 hours. Then I went in and optimized the evaluation pipeline itself, which reduced it down to under 10 minutes. So I was able to run more evaluations quickly. So by the end of all this exercise that myself and Bharat went through, we just not close the gap with the baseline, but we also beat it on our own evaluation set. And we were like very happy with what we got after all this hard work. And right now we have 1.3 deployed, and like folks can use it. Right. So just to talk about a bit more on it. So like when I switched from GPT-4 1106 to 0125, initially, like when I like cherry picked the first initial commit of like from Bharat's branch of his refactor, it was not working well, right? And that time FAISS was used and there were other configurations that were in play. But at the end, like whenever this screenshot was taken from a Slack page, a Slack channel, I said that, hey, I just switched from 1106 to 0125 and it reached 79%, 80%, right? And the change was simple, like LLM switch, but there were more changes that were incorporated. The Chroma DB, retrieving the parents node, like improvement in the query handler, a lot went into it. And just to show you, I started by reproducing the baseline of 72%. And after that, I ran multiple experiments, and all these experiments were based on top of the changes that Bharat was making in his refactor. So there were like 35 unique experiments that I ran, and then that led me to this 74% mark. It was good, right? We beat the benchmark of 72%. Note, however, that when we are doing all this auto evaluation, and this is something that you might also encounter, that if you run evaluation today, you might get say 70%, but you run it the next time, you might get 74%. You might run it the third time, you might get 68%, right? So it's obviously not a deterministic system. When you look at the absolute numbers, like how many were marked correct, the in absolute number terms, the difference is only 2 or 3 examples, but they show up 2 or 3% in 2 or 3 in percentages. So it feels big, but you have to be keep in mind that all these evaluations tend to be in a range from. So when I was able to reach the baseline, it was always in the range of 66, 67 to 72%. It was always, every time I run the evaluation, it was somewhere in that range, right? So when it improved, the range shifted to 72 to 76%, something like that, right? So we ran multiple experiments, and then at the very end, we settled with 81%. Again, this 81% is not something that if I run today, I will get it. Yesterday itself, I was running evaluation again, and I was getting 80%, 79%. I once got 85%, but I'm not claiming that I got 85%, right? So this we take a mean there, right? So once the system was set in place, we were happy with the score on our eval set. We also wanted to do this vibe check. So what is vibe check? We have Wandbot 1.1 system that's deployed, and we have this new system that is giving us a good score on our own eval set. And remember, this eval set was not something that it's not a traditional evaluation set, right? We created it ourselves. And as I mentioned previously, that eval sets need to improve with time as well, right? Especially when you are talking about LLM-based applications. So we wanted to do this vibe check wherein annotators look through, say, 10 examples, like 10 queries were given and responses were generated from both 1.1 system and 1.3 system. And they didn't know which response belongs to which system. Only the owner of it was me who knew which query belonged to which response belonged to which system, right? Annotators had no idea, and they were like doing this blind annotation, right? All they were doing is picking or selecting the query the response which they felt was answering well as per their taste. We did this in internal preference voting, and if I can show you, this is the Argilla workspace that we have, and they're like I designed it so that we can have as like 10 annotate workspaces, and all the annotator were getting the same 10 questions with 1.1 response and 1.3 response. They were just shuffled. So just if I click on one workspace, you see the question. Then we have answer 1 and answer 2, right? So the annotator reads through that. Whatever they find to be more preferred, they select it, and they can also provide some note. And when we did that, like we were able to get somewhere around 1, 2, 3, somewhere around 7 like 5 full annotations and 2 were partial. I don't know why they left one, but we got some good data from it. And when we computed, we got like 60% of the time folks were preferring 1.3 over 1.1. So obviously there is a good signal that our new system, which is giving 80% accuracy on our eval set, is also preferred 60% of the times, which is great, right? And when we did the vibe check and we were satisfied that, okay, this new system is actually better, if not that good, but it's actually better than the old system, we deployed it. And yeah, again, Argilla was used to build this eval set and do this vibe check. That was it. I hope you have questions. If you have, please shoot them away and we will love to answer them.
Thank you, Ayush and Bharat, for the presentation. It was really interesting. And yeah, I really like the last part, how you use Argilla for the vibe check. Okay, and yeah, we have a few questions. The first one is from Krishna, and it is regarding ingestion stage. How did you handle chunking documents so that each chunk is sensible?
Okay, so it started off with an initial decision. First, we tried just recursive character text splitting with different chunk sizes. But then it also, as a developer, I felt like, hey, if I have a markdown document, it makes sense to have semantically relevant chunks. And semantically relevant chunks for us meant chunks under different headers. So if there was a header level 1, header level 2, header level 3, so at different header levels, we would break the document and make chunks. Similarly, we also broke the document when we saw code blocks or tables. So whenever we came across lists, code blocks, tables, we broke them into chunks. This was initially for Markdown. Similarly, for code, we used concrete syntax trees to actually extract different functions, classes, methods, and docstrings and put them separately as separate chunks. And this is what we defined as semantically coherent chunks, right? And then we experimented with different chunk sizes, wherein we then had these small chunks that we would merge with their neighboring chunks to some chunk size so that we could optimize on the context usage. So so the optimal chunk size that we decided on was 512, but it was not that we were using 512 tokens all the time. It just meant that if there were two neighboring chunks and they were shorter than 512 characters, they would be 512 tokens, they would be merged. Only if and only if they're neighboring chunks and they both semantically meant something. For instance, we would never merge two header level 1 chunks, even if they together merged into 512 tokens. But we would also never merge a class and a function outside of a class, but we would always merge a class with its member, for instance, its method, right? If it resulted in a chunk that was lesser than 512 characters. And the number 512 was because we felt like we had to get 5 at retrieval, and 512 into 5 was just lower than the context limit and allowed just about enough tokens for the LLM also to respond in addition to the system prompt that we had. So in all, we were operating at around 4,000 tokens. So yeah, I hope that answers your question.
Okay, the next question is, did you evaluate other embedding models?
I'm doing it today itself, actually. I have been this week. So I have a talk next week, like our fully connected London talk. And there I will be, I'm trying, hopefully I have something done. But the idea is that let's experiment with open source embedding models and compare the performance with the OpenAI text embedding 3 small that we are using currently. And then the idea is to evaluate, then fine tune it, and then see if you can boost the performance. So I'm creating a data set for that and trying to fine tune it and evaluate. So yeah, that's the game plan for this week.
I want to add that right now we've been sticking with OpenAI only because it's multilingual and it's not hosted by us. So we are not really all of Wandbot runs on Replit. So it's really running on a very small machine, and it's just calling OpenAI APIs. And we are not hosting a model. So these are the two main reasons One is it's multilingual, and we don't need to host a model right now, which is why, which is why we stuck with OpenAI. But there was no other reason we did not evaluate other models. Yeah.
Okay. We have here 2 questions. Which part of the evaluation do you think is the most difficult to measure? And the second question, and which part do you think we should pay more attention to when a model does not achieve the expected results?
Yeah, I can try to answer that. The questions are broader in scope, but yeah, in our case, basing on our Wandbot, I would say that the hardest part is to basically come up with the evaluation set itself in the first place. Like the measurement will come later on. The metric that you choose might come later on, but the way you're designing your eval set is gonna be the trickiest part. And once you have that, like once you have employed the methods that you feel comfortable using for your own use case, I think like 2 kind of metrics make sense. One is like the overall, if like an overall metric which is empowering your business. So in our case, accuracy was that thing, because as long as our system is accurate enough that users can get some benefit from that, it is good. It's moving the business metrics. But as well as we need to make sure that, because it's a complex pipeline, like RAG is a complex pipeline, and there are few deterministic systems within the few deterministic components within RAG. So we should have some measure for all those systems as well. Like for example, initially I talked about mean reciprocal ranking and hit rate for a retrieval. Like we did evaluated our retrieval system for V1.0, but we let it go for like 1.1 and 1.3 for various reasons. But yeah, there can be things. It all depend on your use case. And if, like, just to answer the second part, like which part we should pay more attention to when a model does not achieve the expected result. Again, if the model is not like giving you the good results, it can be like one reasoning can be that the eval data set itself is kind of fishy, right? You need to be very confident with your eval set. That's why we, like when I created the initial eval set, Bharat went in and did that alignment of the judge with the human annotations using Argilla, right? So you have to be very confident with the eval set. And once you have that, there can be n number of reasons why the model is not performing good, right? In a RAG pipeline context, the retrieval might be bad. It happened with us as well. Like at some point, we switched the chunk size from 512 to 384. We reduced the number of chunk size, and that deteriorated performance by a lot, right? So we had to move it back to 512. So one thing which impacted the performance, but we noticed. So the whole idea is that create an eval set on which you can be confident, and then do an evaluation-driven development. That's it. That can help you.
Okay, and the last question: how long did it take you to do all this work from exploration to B1.3?
So it's like we started. This is a culmination of our years worth of work, an entire year. But obviously, we were not always working on Wandbot. We have other like roles and responsibilities. But I think every 3 months we visited back and we did a little bit of work. And every 3 months we spent about 2.5 weeks. During V1.3 was when we spent the most amount of time, because getting to 60%, 60% to 72% was easy, but getting from 72 to 80% was more time consuming. And to do that, we had to check through every aspect of our system. And the development work just took 2 weeks, but the debugging and the cherry picking each commit and annotating it, running 30, 40, 50 experiments, that part took 4 weeks time. And and a lot of patience. Like, hopefully some ice cream.
Okay, that was all the questions. So thank you so much, Ayush, for coming today and explaining your work. It's really cool. Wandbot I haven't tried, but I will take a look at the repo because probably we want to do something similar in Argilla. So thank you so much, and that's it.
Thanks for having us.
Okay,
Thanks for having us.
bye.
Yeah, bye.
Bye bye.